Assalamu alaikum, I am Mahfuj Hasan. Today we are exploring Ansible and Terraform, two tools reshaping automation and infrastructure management. This session is all about how automation and infrastructure as code transform the way we provision, configure, and operate systems. Let's break Ansible down into three simple dimensions. First, Ansible is a lightweight automation engine. It is open source and built to automate provisioning, configuration, and deployments without heavy setup. Second, it's agentless architecture. There is no software to install on your target machines. It simply uses SSH for Linux and WinRM for Windows. That alone eliminates a huge amount of operational overhead. And third, human friendly automation. Everything is expressed in clean, readable YAML playbooks, making automation accessible even to teams without deep programming backgrounds. This slide goes deeper into agentless model. At the center is the controller node, the machine that runs your playbook and orchestrates automation across multiple servers. All execution happens through secure remote connections using SSH or WinRM. No agents running on the targets, which means no upgrade, no extra maintenance. It uses a push-based model where desired configuration and push are pushed out from the controller directly to the systems. And all of this is driven by YML playbooks, declarative, reusable, and easily version controlled. This slide highlights why teams adopt Ansible so quickly. Its fast adoption comes from YML's simplicity. Even new engineers can write and read playbooks comfortably. It boosts operational efficiency by eliminating repetitive manual tasks and reducing configuration drift. It's also secure by design because no agents mean fewer update points and fewer vulnerabilities. And finally, it ensures consistent deployment. Every servers end up configured the same way every single time. If we list Ansible's core use cases, the first is configuration management, making sure systems stay in the exact desired state across environments. Second, application deployment, automating installs, updates, and even rollbacks. Third, server provisioning, where new servers are set up with required packages, settings, and configuration. And fourth, routine task automation, handling everyday operation like patching, service restart, user creation, and compliance checks. Now we move into Terraform. Terraform is infrastructure as code, meaning your entire infrastructure is described and deployed through configuration files. It uses a declarative language called HLC. You define the end state and Terraform calculates the steps automatically. It enforces desired state consistently aligning real infrastructure with your configuration. And it supports multi-environment management working across AWS, Azure, GCP, VMware, and even on Palm environments. Why Terraform has become the industry standard. First, multi-cloud flexibility, managing infrastructure on any provider using one unified workflow. Second, reusable modules that provide versioned, repeatable building blocks. Third, state tracking where Terraform maintains a snapshot of your real infrastructure to detect drift. And fourth, scalable automation ideal for large, distributed, and rapidly growing environments. Let's focus on a practical challenge. Manual provisioning slows teams down and creates inconsistency. Ansible solves this by installing required packages, configuring services, applying security hardening, and ensuring every server follows the exact same standard. The outcome is faster provisioning, fewer errors, and standardized environments. Let's talk about another problem. Cloud environments are built manually, slow, error prone, and difficult to repeat. Terraform solves this by defining everything in code: virtual machine networks, routes, load balancer, and firewall rules. It enables version controlled changes, rapid updates, and predictable deployment. The outcome is a cloud environment that is repeatable, fast, and fully automated. Let's wrap everything together. Ansible automates configuration, deployment, and routine operational tasks. Terraform builds and manages the underlying infrastructure across clouds. Together, they provide complete lifecycle automation, from provisioning to configuration to scaling with consistency and speed. Thank you for your attention throughout the presentation. If you have any question, please feel free to ask. Hello and welcome back. For the Ansible task, we need two machines. Here I have two virtual machines. I will use Ubuntu 25 as my control node and server 2 as my manage node. Okay, let's go to my control node and proceed from there. Alright, I'm starting off by updating my system repositories to make sure I have the latest packages. Now I am going to install Ansible using sudo apt install Ansible. Once that's done, I'll just check the version quickly to make sure it installed correctly. To manage my nodes without typing a password every time, I need to up a SSH key. I am generating a new pair here using the ED25519 algorithm. Now I am using SSH copy ID to send my public key over to my manage node, which is at server2 at the rate 192.168.0.215. Type yes and press enter. I will enter the password one last time to copy it over. Let's test the connection. I am SSHing into the manage node, and as you can see, I logged in without a password. I am checking the host name and IP to confirm I am definitely on the remote machine. Okay, logging out and going back to my control node. Now I need to tell the Ansible about the manage node. I am creating a /etc/Ansible directory and opening the host file. I am defining a group called web servers here, adding the IP address and specifying my user and private key file so Ansible knows exactly how to connect. Time to see if Ansible can talk to the server. I am running a ad hoc ping command Ansible all-m ping, and there's the success message, so we are good to go. I'm going to automate an Apache install now. I will create a directory for my playbooks and inside it open a file called installapache.yml. I am defining the task here. First update the apt cache, then to install the Apache 2 package, and finally to make sure the service is started and enabled. Now let's run it. I'm using Ansible playbook and adding the flag to ask the sudo password. If you have passwordless sudo, then you can skip the flag. It's gathering fact, updating cache, and installing Apache. It's look like everything changed successfully. I want to verify that it actually worked. I'm jumping back to the manage node. Let's check the status of Apache 2. It's active and running. And if I curl the local host, I get a default HTML, so the web server is definitely up. Let's log out and go back to our control node. Now I'm moving on to Terraform. I need a few dependencies like wget and gpg. Now this command will add the HashiCorp gpg kit and their official repository to my system source and install Terraform. And checking the version. Perfect, it's installed. I'm creating a new directory called Terraform Lab. Inside it, I'll open a main.tf file. For this example, I am pasting a simple configuration that uses a random provider to generate a string and then saves the string into a local text file named example.txt. First step in this workflow, Terraform init. This is initializing the backend and downloading the provider plugin I need for random string and local files. Now I run Terraform plan. This shows me what Terraform intends to do. You can see here it's planning to create two resources, the random string and the file. That's look right. So I will just run Terraform apply. I will tap yes to confirm and it's done. Let's list the file. You can see example.txt. If I cat the file, I can see the random string I generated. I can check the state of my infrastructure with Terraform show. Since I am done with this lab, I will run Terraform destroy to clean everything up. I will confirm with yes and it deletes the resources I created. Thank you for watching. I hope you enjoyed the video. If you have any question, please feel free to ask.